Okay, so this lab is about accelerated motion. If I was to give a definition of acceleration, what would it sound like?
Change in position over time.
Not in position, but
Displacement.
no, starts with V.
Velocity.
Velocity, right. Okay, so acceleration is when any object has a change in velocity during a time interval. Okay, it's change in velocity over change in time. That's what acceleration is. So that's what we're investigating in this lab. Okay, so the problem, what type of motion is experienced by a car rolling down an incline? Spoiler alert, it might be in the title. Okay, that's what we're doing here. It's a lab on accelerated motion. So you've got to restate the problem in your own words in the form of a question. Change one or two words. Okay? So for our design, looking at our variables. That's okay, I'm recording this. Okay, so for our design, okay, our manipulated variable, as it was in the first one, in the first lab that we did, okay, is time. Whenever we're dealing really with motion of something, how long the object is allowed to carry out that motion is what determines everything about the motion. Okay? So you're welcome. You got the manipulated variable. In this lab, there are actually two responding variables because two things about the cart change as it goes down the ramp. We're graphing both of them. Incidentally, we're making a position versus time and a velocity versus time graph. Okay, so there are two responding variables, and we are graphing them both versus time. You just need to explain how they are going to respond as the cart rolls down the ramp. So in other words, what's going to happen to the velocity and what's going to happen to the position of the cart as they go down the ramp? Now, we need three control variables. What are some things that are going to stay the same? Obviously, we're not going to talk about the angle because we said earlier today when we gathered the data, the only reason we changed the angle of the ramp is just so we would get two sets of data. We're not actually comparing the two data sets or anything like that. We just want to have two sets of data. Okay? But some things that need to stay the same throughout the motion down the ramp. Three things. Okay? One of them has to do with why the cart goes down the ramp. There's something that makes that happen, and it doesn't change. It better not anyway. We're in big trouble. Okay, as it goes down the ramp. Okay, and then the other stuff can be conditional. Right? There's other things. I mean, that's a conditional variable as well. But, okay, think of two other things that are going to be the same for the entire time period during which the cart was traveling down the ramp. And they can be simple, don't overthink. Okay? But in your explanation, tell me why and how they're being controlled. How could they affect the experiment is the why part. What you're doing to control them is the how part. All right. In our hypothesis, here's what I want for the if part. I want basically a definition of acceleration. If acceleration is, you fill that in. Okay, because that's the premise we're working on. Okay, we're working on a lab to do with accelerated motion. Our premise needs to be what we think accelerated motion is. Okay? If accelerated motion is when this is going on, okay, and briefly describe the experiment. So a cart is allowed to roll down a ramp while its velocity and position are recorded. Okay? Something brief like that. Okay? In the then part, I want you to tell me how you'll calculate acceleration from the from the velocity versus time graph? Okay, and again, that's going to be to do with this. Okay, because your velocity versus time graph should have what shape? Okay, when the cart goes down the ramp, what happens to it? It accelerates, speeds up. What does that look like on a velocity time graph? Right, diagonal line. Right, its velocity increases uniformly over time. Okay, what's your position versus time graph going to look like? Right, it's going to be curved. These are the two graphs we should get. You should get one that looks like that, and you should get one that looks like this. Okay, so there's some part of that second graph, that's your velocity versus time graph, that will allow you to calculate the acceleration of the cart. Questions so far? Okay, so we already did the procedure, so we can skip all of that. Okay, you got everything you need from the procedure already. Okay, you will need to plot a graph of position versus time and of velocity versus time. So I'll quickly run through what that looks like here in a minute from the data. Okay, you'll have to delete again a lot of the data in the raw file. Okay, you're not going to need the date and time. You're not going to need the forces or angular stuff. Okay, you need to keep the time. You need to keep the velocity and position for both runs. All right, once you have those graphs built, then you have two analysis questions you need to answer. Okay, first one, using your graphs, and we kind of just talked about this. Okay, identify the type of motion that occurred in this lab and show calculations to prove and explain your reasoning. So, you need to explain why this shape on your position versus time graph indicates that the object is accelerating, and why this shape indicates it's accelerating, and then you need to calculate the acceleration from this graph as your proof. Right? So those are the two things you're going to be doing in question number one. Okay? You can't calculate acceleration from this graph, but its shape tells you something and you need to explain it. Okay? The shape of this graph also tells you that, and you need to explain that, and then this is your mathematical proof. Okay? Find a way to use that as mathematical proof of acceleration. George? Yes. Okay. For question number two, okay, with your graphs, there are two ways to find the displacement of the object. Okay? Compare the values from both methods and explain any differences. All right, so on a position versus time graph, so this one here, I should be able to calculate displacement, right? Usually we calculate displacement like this. Okay, and when I have a velocity versus time graph that looks like that, I should be able to calculate the displacement from that graph as well. There's a couple of ways to do it, okay, and either way would be valid. How should the number I get here and the number I get here compare, theoretically? They should be the same, okay? They're not going to be exactly the same, but they should be close. Like I'm saying within 10 centimeters for sure, okay? If you are out by more than 10 centimeters, then you did something wrong somewhere along the way, okay? But these two numbers should be very, very close. All right. Correct. Then you have your conclusion. Okay, so copy paste your hypothesis. Were you able to do in the analysis what you predicted in the hypothesis? Okay, and then accept or reject. Two sources of error and ways to fix them. Right, and that's it. You don't have to do the class discussion. We'll talk about that when I hand back the labs. Are there any questions there? Okay, I'm going to quickly run through the graphing stuff just in case anyone's kind of lost on how to build the graphs. I have a couple of tips and pointers for making the graphs work here. Okay? So when you get your graphing data, it's not going to look like this. It's going to have all of the other columns. So let me see if I can find something like that. Okay, sorry guys, I don't seem to have like the full on. I don't seem to have the full on one that has all the other data. So here's what you need to do when you're sorting through your data file. Okay, whichever one of your trials was the longest, that's the time column you keep. Should be run 1 because that was going to be our shallower of the 2 inclines. So that one should have taken longer than the second one did. Okay, so you're going to keep that. Okay, and you're going to make that your time column. Now what you're going to have to do is you're going to have to make one sheet your position versus time data, and one sheet your velocity versus time data. I realize my data has 3 runs. Okay, you're only going to have 2, and that's fine. No question.
Is it okay if the second one has the one time?
Yes, you just have to make that your time column. Okay, so your time column needs to go first. Okay, so what I did is I just copied all the data after I pulled out all the stuff I didn't need. So when I had like position and velocity time data, okay, I pulled all that and I just copied it to a second chart. And then I took out all the position data for this one, and I took out all the velocity data for this one. So I had one sheet that I'm going to build my position versus time graph from, and then I had this sheet that I'll build my velocity versus time data from. Here's the key. The time needs to be the same on both sheets. If it isn't, your value for displacement between the 2 graphs could vary more than 10 centimeters because one graph is about more time than the other. Okay, so you need to make sure you have the same amount of time, okay, on both of them. Okay. All right, so when I'm building the graphs, okay, remember I just highlight all my data, okay, and I'll only highlight 2 runs, okay, and then this is you. Okay, so I insert chart. All right, and I don't want a line chart, I want a scatter plot. So you may have to do this and go down to scatter. Perfect, okay? That data is perfect. I wonder who collected that. Okay? Got nice curves for my position versus time graph, no question.
And we don't need any of the acceleration or velocity?
No, no, you need velocity. Okay, you need position and velocity for each run, and whatever of your ones was the longest, to keep that time. Okay. All right, so I set that up there, and I would obviously have to put in a label here and change my title. Okay, and then for this one, I don't need a best fit line. I'm not doing any calculating for this, and it's a curve anyway, so I don't need to do anything else. I just need the shape of that graph. I copied into my lab report. Okay, then I've got to do the velocity versus time graph. Okay, so I insert chart. Okay, and this is what Google Sheets does. It tries to anticipate what kind of graph you want and fails miserably. Okay, I do not want a column chart. I want a scatter chart. two perfectly straight lines, just like we would expect. Okay, so now that I've got those, then I'm gonna go to customize. These ones I do need a best fit line for, so that's in series. Okay, and then we go down to trend line and check that box. Now we get a trend line for each one, and then for the label, so right here where it says none, I click on that and I ask it to put out the equation. Boom. Y equals 0.612x plus 0.319, and y equals 1.25 times x plus 0.438. Okay, so I've got the equations for both of those on the velocity time graph. If I went too fast for you, I'm recording this right now. You can always come back and catch it again.
And you can press like for label, like with the equation, do you do that also for the position?
No, you don't need it, because it's a curve. It's a curve, so you're not gonna be calculating anything from that graph, so you don't need it for that. Okay, questions there, guys? All right, we got about 15 more minutes to work on that lab report right now. Okay, so you got the rest of class to work on the lab report. If there's questions or you're having trouble, let me know, I'll come give you a hand.